Everybody, Mr. Mack here, and today we're going to go over some review problems for our Chapter 7 cumulative assessment. So let's jump right in here. We are solving for sides and angles, and I said round to the nearest tenth, but for this one right here, we know that this is a special triangle because we've got 90, 60, so x here, we know that x has to be 30. So now we just need to get W. So how about we label these sides here? So 9 is our hypotenuse of this triangle. Side BC right here is going to be our short leg because it's opposite the 30. And side W here is going to be the long leg. It's opposite the 60. So we know that the hypotenuse in a 30, 60, 90 is 2 times the short leg, and we know the long leg equals the short leg times root 3. So our hypotenuse is 9. Our short leg is, let's call this y. So 2 times y. So y is going to be 9/2. This is our short leg. I could take this value here and pop it into the short leg equation right here, and that would give me W equals 9/2 times root 3, and it's already good to go. There's nothing more to do. So x is 30 and W is 9/2 times root 3. Now if we did that on the calculator, we get a decimal. And how about, since I know some of you are going to do that and you're following instructions, that's 7.79. And round nearest tenth. So that would be 7.8. Some of you may have also used our SOHCAHTOA functions, in which case W is opposite and 9 is the hypotenuse. You could have also used sine of 60 equals opposite W over 9, and then you multiply 9 to both sides. And if you did that, let's see here. Where is my web 2.0 calculator? So 9 times the sine of 60 is 7.79. Same. So we get 7.8 that way as well. This is an exact answer, the 9/2 root 3. And the 7.8 is rounded. So really the better answer is the simplified radical form. However, when asked to round to the nearest tenth, we could do it the other way as well. All right, let's look at this next one. 45, 90. Well, what does x have to be? Has to be 45 degrees. And so we know that the legs are congruent in isosceles triangle. So W is also 15. And now we're looking for z, which is the hypotenuse. Wow, how many ways could we solve this? I mean, we know Pythagorean theorem. So let's see, Pythagorean theorem, that's 1. We can use our special triangles, that's 2. We could use sine function. We could use the cosine function. And that's it. So 4 ways we could use to solve z. Let's use our special triangles. Hypotenuse is leg times root 2. That's our equation for special triangles, 45, 45, 90. And so z is our hypotenuse. Our leg is 15 times root 2. And that's our answer. Now, that's an exact answer. If we were to round this, I'd just put this in the calculator. 15 root 2. 21.2. We could have also used, how about we do sine again? So sine of 45 equals the opposite leg, 15, divided by the hypotenuse, which is z. I need to multiply z to both sides, and then z sine 45 equals 15. I have to get rid of the multiply sine 45 by dividing it. Calculator, 15 divided by sine of 45, 21.2. Same as what we got there. Okay. All right, this is not a special triangle. We're going to have to use SOHCAHTOA. And so let's see, we have 64. X is the opposite leg. Y is the adjacent leg. 50 is the hypotenuse. So let's do x first. So which function do we use for opposite and hypotenuse? So SOHCAHTOA. Opposite and hypotenuse, that's so. So we're going to go sine, what's our angle? 64. Equals, what's opposite? X. What's the hypotenuse? 50. We're looking to solve for x. We need to get rid of the divide by 50 by multiplying 50 to both sides. And then we go to our calculator. 50 times the sine of 64. 44.9. That looks good. Y is the adjacent, and we know the hypotenuse. That's going to be cosine. Cosine of our angle 64 equals y over 50. I'm going to multiply 50 to both sides, and 50 times the cosine of 64, 21.9. Box that in, maybe. Okay. Okay. X. X is an angle, W is a side. Let's do X first. So X is an angle. We know the opposite leg, and we know the hypotenuse. So which function uses opposite and hypotenuse? That's sine. So we have sine of this angle, x, and it equals 12 over 20. So we can simplify this. 4 comes out of top and bottom. So 4 out of 12 is 3. 4 out of 20 is 5. And now, how do I get x by itself here? How do we get rid of the sine that's wrapping around this x? And so what we need to do is we need to take the inverse sine of 3/5. So we want to see what angle goes with the ratio of 3/5. So we do inverse sine of 3/5. There we go. Now arc sine is another way we can say inverse, and we see it on some calculators, but you can see right here we see the sine to the -1, and we read that inverse sine, and then equals 36.9 degrees. Okay, that's our x. And what do we do to get our y? Well, rather w. So w is the side. Look, the best way to get w is just by using Pythagorean theorem. I could use this angle and use another trig function, but this angle is rounded. I'd rather keep with given values. So really, Pythagorean theorem is better method. So let's say 12 is our a value, and we'll make w b, and then 20 is our c value for the Pythagorean theorem. So 12 squared plus w squared equals 20 squared. So w squared equals 20 squared minus 12 squared. And so 20 squared I know is 400, and 12 squared I know is 144, but just do this, 256. And then we have to take the square root of 256. And, well, you know, I said we could round to the nearest tenth, so we could go to a factor tree here and start dividing this thing up. Right, 2 goes in, and what would that be? 128, and then let's see, well, 264. But I think what we're going to see here is this is a perfect square. So if I take the square root of this answer, and it's 16, and we would see that if we kept going here, 232, 2, 16, 2, 8, 2, 4, 2, 2. Got a pair, another pair, another pair, and another pair. 2, so that means a 2 times 2 times 2 times 2. That's 16. So actually, the square root of this is 16. Perfect square. Sweet. Okay, there we go. One of these problems. All right, so please recognize this right triangle is being inscribed by another set of right triangles. So we have a very yellow screen. This is what we have. We have that yellow triangle, and we have that orange triangle. And what do we know these triangles are to each other? They are similar. So we know that the long leg of the medium-sized triangle here divided by the short leg of the medium, let's say medium, equals the long leg over the short leg of the small. Because that's what that's a property of similar triangles, right? The ratios of corresponding sides are going to be the same. And we see that this is the same as the geometric mean. Cross multiply, what I'm doing is I've got w squared on this side, and I have 16 times 4 on this, and then we take the square root. And we've seen this formula before. The geometric mean equals the square root of a times b. And in this case, a is 16 and b is 4. Well, what's the square root of 16? That's 4. What's the square root of 4? That's 2. And then 4 times 2 is 8. We could multiply this together and break it down, but sometimes it's easier to work with numbers when it's separated. So that's 8. And now how do we get x? So I know the opposite leg here is 8, and I know the adjacent leg here is 16. So therefore, I can use tangent of x and set that equal to opposite leg over the adjacent leg. And 8 over 16 is 1/2, but I have to take the inverse tangent of this. So I'm going to take the inverse tangent of both sides. And instead of writing 8 over 16, I'm just going to do 1/2. You can actually do the inverse tangent of 8 over 16 and get the same answer. Inverse tangent of 1 divided by 2. There it is. 26.6. That's an angle, so I'm going to put my degree symbol there. Just so you see, if I go back up here and I were to do 8 divided by 16, you get the same answer. It's still 26.6. Okay, nearly there. Determine if the following triangles are acute, right, or obtuse. Okay, so we didn't really talk about this, and this will not be on the quiz, but let's reason it. We know that the Pythagorean theorem is a squared plus b squared equals c squared, and if we substitute the smaller values in for a and b and the larger for c, and it's true, if this is true, then it's a right angle. If it satisfies the Pythagorean theorem, it's a right triangle. What would happen if the legs were larger? Or let's see, if the sum of the legs, square of the legs were larger. And let's think about this. Say we had an equilateral triangle. And so how about all the sides were 2, right? And so, okay, we're just going to put in all of our values here. So 2 squared plus 2 squared equals 2 squared. This is obviously not true, but 4 and 4 is 8. So 8 is greater than 4. So if the legs are greater, the sum of the legs are greater than the hypotenuse, this is what, so is this obtuse? No. A equilateral triangle is acute. So this will give us a right triangle if a squared plus b squared is greater than c squared. It's going to be an acute triangle. And then if the c squared part is greater, like this, it's going to be obtuse. That's it really for this. Pretty simple. So we're just going to put these values in. 8 squared plus 9 squared and 10 squared. And we're just checking to see which way the inequality goes. These are clearly not going to be equal, right? So you got 64 and 81 and 100. Well, 64 plus 81 is clearly greater. So this is going to be acute, this triangle. And we can think these numbers are almost like an equilateral, right? They're not exactly the same, but they're pretty close. 14, 48, and 50. So we do 14 squared plus 48 squared, and we're checking to see how that compares to 50 squared. So we got 14 squared plus 48 squared, and that gives us 2,500. Oh, well, I hope we know that 50 squared is 2,500, right? 5 times 5 is 25, and then 2 zeros. These are equal. So this is a right triangle. And, well, I guess by process of elimination, this one's going to be obtuse, right? Is that how it works? So 5 squared plus 12 squared. And we're checking to see how that compares to 15 squared. 25 plus 144. And, 15 squared is 225. And, this does, to 225 is bigger than these two to add it up, right? This is 169. So this is obtuse. Okay. Cruising right along. We're on the last one here. It has a couple of parts. From the hot air balloon, Mac spots Luntz leg strong at an angle of 22. Let's see. From how about Mac spot? So this is Luntz down here. And I thought it was Iron Mac, but it's Luntz. This is Mac right here. And angle of depression, how does that work? That goes from the horizon down. So here's our horizon. And this angle right here is 22 degrees, yes. The altimeter in his balloon showed an altitude of 2020. So that means this vertical line right here is 2020 meters. It's pretty high in the air. He's over 2 kilometers in the air. Okay. Hope he has a sweater. And how many meters away is leg strong to finish the finish line if the balloon is directly over the finish line? So we're looking for this length right here, this distance. Call it D. All right, so the ground is horizontal. This horizontal line up here is horizontal. These are parallel lines. We know that this is also 22 because this is alternate interior angles. And now, I could also find this angle right here. Maybe we said, oh, well, we know this has to be 90, right? So 90 minus 22 is 68. So I got all the angles here. I'm going to use a 68, I think, this time. So I'm looking for D is the opposite of 68. And 2020 here is adjacent. That's tangent of 68 is D over 2020. So we have to multiply 2020 to both sides. And we go to a calculator. Ooh, 5,000. How are we rounding this? Well, I'm rounding it. 5,000. 5,000 meters. Well, how many kilometers is that? 1 kilometer is 1,000 meters. So therefore, this is the equivalent of a 5K, 5 kilometers. All right, now, if leg strong is maintaining a speed of 50 kilometers per hour until the finish flag, how many minutes will it take him to finish a race? Okay, well, this is an extra thing, so won't see this on any assessment, but distance equals rate times time, or I could say speed. I know that distance equals speed times time. Okay, so his distance, he's got 5 kilometers distance, and he is going 50 kilometers per hour. And we're looking for the time. So if I divide both sides by 50 kilometers per hour, what happens is, it's a 50. 5 over 50 is 1/10 of an hour. And we know that there are 60 minutes in 1 hour. So if I multiply this by 1 hour on bottom to cancel hours, and 60 minutes on top because I want minutes, 60 times 1/10 is 6 minutes. It will take him 6 minutes to do that 5K. Decently fast. Okay, that's all we got for this one. A little more review on some SOHCAHTOA, inverse, some Pythagorean theorem. Threw a little special triangles in there. I got some similar triangles as well. Angle of depression, angle of elevation. Thanks, guys. See you later.